Hello everyone. Today we're going to start talking about polynomials. This is our last chapter in Algebra 1, so throw yourself a little internal celebration. You are almost done. And this is how we're going to close out our year, is with polynomials, which sound a lot scarier than they really are. You've actually been working with polynomials forever. You've just never called them that, okay? So that being said, let's get a nice, scary, complex math definition for polynomial written down. A polynomial is an expression made up of variables and constants that are combined using addition, subtraction, and multiplication with whole number powers. Whew, take a minute, write that down. Please feel free to abbreviate. There's lots of places in there for abbreviation. And then I'll tell you what all of that scary stuff means. Okay, so let's take this apart piece by piece. An expression, you know an expression in math is just like a mathematical phrase. It doesn't have an equal sign like 2 plus 3 is an expression, okay? Made up of variables, so letters, and constants, which means numbers. I guess I should also throw coefficients in there, which remember coefficients are numbers that are attached to variables. And they're combined using addition, subtraction, and multiplication. Pause right there. What is missing from that list? Hopefully you're seeing division. We don't divide by variables with polynomials. You may have something like x divided by 4, because that's really the same as 1/4 x, but you're never going to have an x on the bottom of a fraction. That's going to be important later on. With whole number powers, okay? So whole number powers means you're always going to have whole numbers up here. It's not going to be fractions. It's not going to be negative numbers. It's going to be just nice, happy exponents. So this right here is an example of a polynomial. Notice you've got some x's in there. You've got some pieces that are separated with pluses and minuses. You've got exponents. You don't always have to have exponents in polynomials, but you often do. And that's really it. That's what a polynomial is. So there's a bunch of different ways or a bunch of different pieces of a polynomial, okay? A bunch of different terms that we use to describe them. The first one is the degree. The degree is the largest exponent on the variable, okay? So if you look at your whole polynomial at all of the pieces, the largest exponent that shows up is the degree. This example up here, the 4 would be the degree. So I would say that this polynomial has a degree of 4. Standard form. When I write something in standard form, and we've talked about standard form before, the polynomial is written in descending order of exponents. Descending means going down. So I start with the biggest exponent and then I work my way down to the lowest exponent, or no exponent at all. In this case, see how the 6 doesn't even have an x on it? So there's no exponent there. Okay? So see, I went 4, 3, 2, this would be a 1, and this would be like a 0. And that's standard form. Leading coefficient. So coefficient, remember, is a number that's attached to a variable. Leading means it's in front. So the leading coefficient is the coefficient on the first term in the polynomial. It must be written in standard form for you to be able to call it a leading coefficient. So because this is written in standard form, my my leading coefficient would be this 2. And term, the pieces of the polynomial. So you've got pluses and minuses in here. The chunks that those pluses and minuses are separating, those are the terms. So this is a term. 2x to the 4th is one term. 3x to the 3rd is one term. X squared is one term. 5x is one term, and so on. I'll give you a second, let you get that written down. Okay, there are some different ways to classify polynomials, some different things that we call them. A linear polynomial, we almost started the year with that. That was like the second chapter that we did was linear equations. Those are linear. A linear polynomial is a polynomial in the first degree, which means that the highest exponent you'll see in a linear function is 1. Okay? So let me just write out an example of that real quick. If we wrote y equals x plus 5, that's a linear polynomial because the highest exponent we have is a 1. All right, both of these have a 1 on them. We don't usually write the 1, but they do have a 1. If I had any other exponent there, that would not be a linear function anymore. So remember, one of the things that we talked about when we talked about linear functions is they couldn't have any exponents. Technically, they can have exponents, just they can only be a 1. Okay, quadratic. We've talked about quadratic functions before, too. Quadratic functions always have a square in there somewhere. So that means that a quadratic polynomial is a polynomial in the second degree. And second degree, meaning that there's an exponent of 2, that the highest exponent that shows up there is an exponent of 2. Okay, so quadratics, that was back in chapter 6, right before Christmas break. And something like this was a quadratic function. Okay, remember you could solve this with the quadratic formula. We could graph it and it would make a parabola. So you're already familiar with this type of thing. That 2 there means that it's the second degree. So then what do you think cubic is? Cubic is a polynomial in the third degree, meaning there's an x cubed in there somewhere. And quartic is a polynomial in the fourth degree. Okay, so pretty straightforward there. Give you a second to make sure you have those written down. Beyond quartic, we really don't have special names for them. So if it has a degree of 5, we just say it's the 5th degree. We don't have a fancy name for it. Okay, so here's an example. It gives us a polynomial, and first it tells us to write the polynomial in standard form. And remember, standard form means exponents from biggest to smallest. So first I would go through and I would kind of separate your terms. We've got negative 2m to the 4th. We've got positive 3m. And notice how I'm kind of grouping the symbol that's in front of it with the term. That's going to be important. Because something like this, for example, this 5m squared that has the minus in front of it, we really need to treat that like a negative 5m squared. Okay, so there are my 5 terms. And if I was going to write it in standard form, I'm looking for the biggest exponent to start. That'd be this right here, because it has an exponent of 5. So I would start with 6m to the 5th. And now I've used that one. My next one would be this power of 4 here. And that has a negative sign in front of it, so I'm going to write it as minus 2m to the 4th. Let's cross that one out. Next biggest one I see is this power of 2, and that also has a minus sign in front of it, so I'm going to write negative 5m squared. Cross that out. Next up would be the one that just has an m, because that, whoops, didn't mean to scribble there, because that's like an exponent of 1, and that has a plus in front of it, so it gets to keep its plus. And then my last term would be this 1 because it doesn't have an m at all. It doesn't have a variable at all, so then it would be plus 1. So that's standard form. Identify the leading coefficient. Remember, you can't do this until it's in standard form, so we need to look back up at this part that I just did. Leading coefficient is the coefficient in front, so that would be way up here at the beginning, and it would be the 6. Okay, so the leading coefficient is the number that's in front of the variable in the very first term. And then degree of the polynomial, remember that degree is the largest exponent you see anywhere in your polynomial. If you're written in standard form, it should always be in the front. So this one would have a degree of 5. And what I was saying on that last slide is we don't really have any special names for that. You know, it's not quadratic or cubic or anything like that. We just say it's a fifth degree polynomial. And I can't see that last question on my screen, but I think it says give the number of terms. Well, the number of terms is the number of pieces that we had to put together. So that's 1, 2, 3, 4, 5. So this one has 5 terms. Okay, this is one very specific example of a way that you could use polynomials to set up equations. I'm doing this one specifically because there's a question just like this on your homework assignment tonight. Okay, so starting the summer after her senior year, Yolanda worked to save money for medical school. At the end of each summer, she deposited her money into an account with an interest rate of R%. She plans to attend medical school after her 4th year of college. So basically what's happening here is this money that she's putting in after her senior year is going to sit for 1, 2, 3, 4 years. This money that she's putting in after her 1st year of college is going to sit for 1, 2, 3 years. This money is going to sit for 2 years. This money is going to sit for 1 year. And this last money, the one she puts in after the 4th year of college, that's getting spent almost right away because she's going to medical school that same year at that same time. Okay, so this money's not going to sit for any time at all. But all these other ones she's going to earn different amounts of interest on. There's one very important key to starting out this problem, and I may have left this written on your paper, I'm not sure. But I want you to think back to when we talked about exponential growth. And with exponential growth, remember that when I gave you a percentage growth, you always had to add it to 100% because you were keeping 100% and then adding onto it. That's what happens with interest rates too. So if you deposit $100 in the bank and you get 3% interest, you keep 100% of your money and you add 3% on. So you really have 103%. Remember that what you would end up putting in your problem then would be 1.03, okay? So all of our percentages are going to have a 1 in front of them. And so to sort of handle that and to make this look a little cleaner, I would say that we are going to represent 1 plus r. So that's that interest rate with the 1 in front of it, okay? So that this is the 100% of our money that we're keeping, and then this is the interest that the bank is adding on. We're going to take that 1 plus r and just call it x. And that way we don't have to write 1 plus r every time. Okay? So after her senior year, she's depositing $1,500. And she is going to earn our interest rate on that. So we're going to multiply that by x. And she's going to earn that interest for 4 years. Remember we just talked about if she gets that after her senior year, it's going to sit for the 4 years she's in college. So she's going to get that interest rate multiplied 4 times. If you're multiplying something 4 times, that's like an exponent of 4. Okay? Then we're going to add on the money that she's depositing after her 1st year in college. After her 1st year in college, she's going to put $2,200 in. It's also going to earn interest, so we're going to put that x there. And it's going to earn interest for 3 years, meaning it's going to get multiplied 3 times. Okay. After the 2nd year of college, $2,100. And that will earn interest for 2 years. After her 3rd year of college, she's depositing $3,000. And that's only sitting for 1 year. So it's only going to get multiplied 1 time by the interest. And then after my 4th year of college, I'm going to deposit $3,300. But that's going to get spent almost right away because I'm heading to medical school that same summer. So that's not sitting for any time, meaning I'm not going to earn any interest on it. So this is what my polynomial would look like. So instead of that x, if I had wanted to, I could have put 1 plus r in every place. And again, that 1 plus r means the 100% of your money you're keeping plus the interest rate that the bank is going to add on. And that gets multiplied every year. Remember compound interest? Okay, it's being compounded once per year. Okay, Now it says, if she earns 6% interest rate each year, calculate how much she will have saved. So all that's really doing is that's telling you what R is. Okay, that 6% means this R here is 6%, which means instead of 1 plus R, we're going to say 1 plus, let's see, 6% would be 0.06. So I'm just going to write this as 1.06. Okay, and that is what I'm going to plug in for X. Okay, because now I have my interest rate calculation. I'm going to multiply by 1.06 every time. So now I'm just going to put straight into my calculator 1,500 times 1.06 to the 4th power. Again, just so you understand where this is coming from, I'm depositing $1,500 after my senior year. I'm keeping 100% of that, plus the bank is going to pay me 6% interest for 4 years. Okay? Then I'm going to leave that money in the bank, but a year later I'm going to put $2,200 more in. And now I'm going to multiply that by 1.06 for 3 years. Then 2,100, 1.06 for 2 years, 3,000, times 1.06, just 1 year on that one, and then just plus another 3,300. Okay, let's start typing away. When I type that massive equation into my calculator, let me see if I can shrink that up so you can see the whole thing. It should go there. When I typed that massive equation into my calculator, I ended up with a grand total of $13,353.51. And that would be the answer to my question. That's how much I would have saved earning 6% interest per year. So again, that's not a super common use for polynomials. That's sort of one very specific type of problem. But I do know that shows up on your homework assignment tonight, so I wanted to make sure you had a good example of that. So when you hit that problem, I don't remember what number it is, but when you hit that problem, please look back at this example. Okay? Homework assignment tonight is 11-1B. You can go ahead and get started.